All right. Thank you so much for the introduction, Lucy. So my name is Sergi, founder and CEO here at Quilter. Before founding Quilter, I was an electronics engineer at SpaceX for about 5 years. I started off in the EMI group and then switched to the radiation effects group, and really, designed a lot of boards, helped the team design a lot of boards, and ran into a lot of kind of the common challenges that we all run into when designing electronics, which was really the inspiration to start this company and to try to push the technology forward. So we've been working on our side of things for about 4 or 5 years now, and are kind of happy to be starting to share it with the world a little bit. And so I'll let Ben introduce himself a little bit. I'm sure most know him, but nevertheless, for those who might not, Ben, if you could say a few words.
Hi everyone. For those who don't know me, I'm staff electrical engineer at Quilter, and I joined this company because I could really see what Sergi's vision was, and the Quilter team, for where hardware design at the board level was going was really in line with thoughts I'd had for a long time, but I wasn't at the time going to make it myself. Uh, Being more of a hardware designer, and I could just see this is really going somewhere. So I wanted to get behind them. I joined Quilter uh, at the end of April last year. And before that, I had a few years as a contractor. Before that was a senior product manager for Fusion 360 Electronics over at Autodesk. And before that was actually with Altium as a product manager and product marketer for almost 16 years. So kind of an EDA guy, and very opinionated about where I think this technology could and should be helping us. So I'm very happy to be joining the webinar today as well.
Awesome.
Sorry, I forgot to mention a couple of things. So everyone, I will send you the slides and recording this afternoon. And also, Sergi and I were discussing before we launched the webinar. And we were thinking that we would like this to be more of like an open discussion. So if you guys have any questions during the webinar, feel free to ask in the Q&A section, or you can even do something. You have the option to raise your hand. And if you do so, I will let you unmute yourself. So you can just unmute and talk to us directly and ask your questions, which I think is pretty cool. Thank you so much for doing that, Sergi.
Yeah, no, of course. I really want to welcome that as much as possible. I don't like delivering a monologue any more than anybody likes listening to a monologue. So by all means, everybody, please, easy questions, hard questions, whatever comes to your mind, go for it. We're all open for a discussion here. All right. Well, so without further ado, let's jump in. So the kind of thesis for this discussion here is that time matters, right? Time matters a lot. So it turns out, and this is not necessarily obvious to folks, that time to market actually drives cost overall for a company a lot more than the budget to develop something, right? So if you consider these two scenarios here, right? If you're developing a product and you develop it to a strict budget, but it arrives 6 months late for one reason or another, overall, a company that produces that is estimated to have a 33% profit loss. But in the other scenario where you go over budget on designing your product, but you deliver on time, you end up having only a 4% profit loss in comparison, right? This is a study by McKinsey, which we'll source, that the folks are, of course, welcome to review. But the point to make here is that being late to market is a lot more costly than the extra budget to get to market on time, right? And so a part of what we want to kind of convey here is that there are new capabilities and new tools that are coming onto the market, new capability both on the fab side from Sierra, which we'll talk about, that we're super happy exist, and of course from our side and other startups that are coming online that allow us to make this more possible, right? To deliver projects on time, ideally not over budget, but if they have to be, then so be it. And the second thing that kind of implies is that you need not only to look at the tools that kind of make this possible, you also need to look at the culture, right? So there's a discussion that we should have as hardware developers about how we run hardware development processes and how we leverage new tools to change how we approach the process in order to kind of achieve these results, right? So one of the places where this has already shown up, and this is nothing new, but it kind of further reinforces the point about time, right? Is this switch that has happened in hardware from, the waterfall design process to the agile process, right? So for those who might not be familiar, the waterfall process is this kind of a traditional concept that you have certain sequential steps that need to happen. Each one needs to happen perfectly and be locked down, and then you pass on to the next step, right? So in this case, like you're starting with a concept, then you go into a design phase, you lock down the schematic, review it really, really carefully, pass it off to layout, review that carefully, simulate it, then you go through your bring up and so on and so on and so forth, and you do this sequentially. And the kind of the issue that comes up is that almost without fail, all of these individual steps end up being late, right? Things take longer than you think. Um, and furthermore, a lot of times you discover issues in the previous step once you've started a subsequent step, right? You discover a schematic issue in layout, or worse, after the board has been built. And so for that reason, one of the historical kind of culture shifts that has happened is the introduction of agile in hardware development, which is basically just this concept of iterate fast, right? Start with a concept, develop and design a solution as quick as you can, build it as quick as you can, and test it. Learn from that test, and do it again and again and again. And this, you know, relaxes a little bit the constraint on getting everything perfect on any individual step, and allows you to discover the unknown unknowns that you tend to discover once you get to the test steps, right? And since this process has been kind of run at multiple companies for a while, we have some data to show that that it's actually producing really good results, right? So a couple of studies here that we can source to, again, to McKinsey and Scrum Inc. and a couple others in the resources, that are showing that approaching hardware development this way, with this kind of agile mentality, can improve time to market by as much as 60%. And I think in my notes here I have that some departments at John Deere were improved by like 80% because of this. So the culture shift to developing hardware quickly is just as important as the tools that make it more and more and more present, right? But the problem is that at the end of the day, like, you can make organizational changes all you like, and that doesn't change the fact that hardware is ultimately hard, right? So as an example, PCB layout just still takes weeks for most boards, no matter how you spin it, right? Even the simplest, easiest board takes a day, and some boards take months, and no amount of Jira tickets is going to speed that up necessarily, right? We also have in this industry a significant shortage of engineers, right? There's everybody kind of tells us when we speak with their companies that there's never enough PCB designers. This is partially because we're not graduating nearly enough electrical engineers, partially because the PCB designers who are out there today are an aging population and starting to retire. At the end of the day, it's hard to predict all the possible issues that are going to happen with the design. And so, debugging, bring up validation, compliance testing, EMI testing, and in aerospace companies, obviously, hundreds more tests take a really long time. And all of this just forces those loops to be slow. And so because of that, you can only get so many iterations, and kind of agile hits a limit from just an organizational perspective. But the thing we want to challenge here today in particular is that some of these assumptions that have been true in the industry for some time are really starting to change. So, for example, taking a nod here to Sierra, which they'll speak to this a little bit more in a moment. Production of PCB and PCBA has really, really, really sped up, right? Like, most people we talk to at Quilter designing boards assume that getting a board back from fab is going to take at least a week or two, and especially if you go down to thinner trace in space or 6 layers or more, or so on and so forth, then you're looking at a minimum of 2 weeks, and that's just no longer the case, right? At this point, and I'll let Sierra speak more to this, but they have fast turn capabilities that go much, much more quickly than that, which enable us to look at new capabilities. Sierra is also pioneering automation of DFM and DFA, so that we can get feedback on the designs much more quickly, rather than waiting for a manual CAM review. That allows us to shorten these loops. And aside from fabrication, On the design side, there's a wave of new companies coming in to tackle these problems as well, right? So aside from us, companies you should probably know about, like DeepPCB, JetX, Flux, CircuitMind, Celis, Dempaflux, and a bunch of others, are starting to tackle various parts of the design process and asking, how quickly can we get a first version out, right? So in particular, shout out to CircuitMind, who focus on how do we go from a conceptual block diagram of what product we want to a selection of parts and an actual drawn schematic, ideally automatically, right? And so that's something where, instead of taking a few weeks even to research parts in DigiKey and to draft up schematics, read a lot of data sheets before you can even attempt doing a first build, potentially you can have a first stab almost instantaneously if you can just draw the block diagram. And of course, other companies like us are focusing on a layout, which we'll talk about a little bit more. But then there's also companies like Dempaflux focused on EMI, EMC verification before build. And so what we're really seeing is that all throughout the stack, starting from a block diagram of what product you want to build, through schematic, through layout, through simulation, EMI verification, through manufacturing, all the way back to a board on your desk, all of those are compressing, right? All of those are potentially going from weeks to even hours in some cases. And so we really have to question, what does that mean for our kind of cultural development process? How do we iterate more quickly, given that that's possible?